Hello, class. So we're starting with section 1.1 in your textbook, okay? And section 1.1 is about numbers, okay? Specifically about the set of numbers, okay? So we're going to introduce these fancy numbers or letters, okay? So here's an N, all right? And this symbol stands for the natural numbers, okay? And the natural numbers are called that way because they're the ones we naturally learn when we're kids. So like 1, 2, 3, so on and so forth, off to infinity. Okay. And then like a big deal. Okay, so big deal is notice, okay, 0 is not a natural number. All right. And that's a pretty contentious fact. Some books argue that it is. Some books say that it's not. Some professors say that it is. Some don't. Okay. We don't treat zero as a natural number in this class. Okay. The other thing you'll notice is these curly brackets. Okay. Those mean that we're dealing with sets. Okay. So when we talk about sets, it'll be curly brackets and then stuff inside of the set. Okay. In this case, it's numbers. Okay. Moving on, we're gonna get this z here. All right. And these are the integers. All right. And so the integers are basically if we take the natural numbers and go left. Okay, so we go negative infinity, -2, -1, 0, 1, 2, forever. Okay, so the integers, sometimes we also call these just the whole numbers, right? Because they're all of the numbers that aren't fractions. Okay, so integers. All right, and then moving up again is like we're kind of gonna fill in the gaps, okay, in a way. So we have this Q, all right, and this is the rational numbers. Okay, so the rational numbers are all of the integers, but now we're allowed to have basically anything that's a fraction. Okay, so like 1/2, all right, 3/2, square root of 4, okay, all of these things rational. And then so here's where you get the question really of like what is rational, right? Because some of these things look rational, some of them aren't. So if it's a whole number, automatically rational. And if it's a fraction, automatically rational. Okay? But when are decimals rational? Okay? So decimals are rational. All right, when they end, so when they terminate. Okay, so if they don't go on forever, automatically rational. And then if they do go on forever, okay, when they have a pattern or when they repeat. Okay, so if they have a pattern or repeat forever, then it's also a fraction, okay? Those are the two times decimals are rational. Or you could just think about it as if the decimal just is a random pattern that doesn't exist ever and goes on forever, then it's not rational. Okay. So like 1.5, 1.9999 forever. Right, like 1.75 forever. Right. So if the bar, right, the bar kind of means 75, 75, 75 forever. Okay. So all of these things are rational, okay? And I'm going to introduce this symbol, this kind of like weird curvy E thing. All right, this is the symbol that means in or belongs to. Okay, so that's that math symbol, okay? So why are patterns rational? Okay, well, some of you probably already know, but like 0.33 forever, right? 33333. That's 1/3. 1/3. Okay. And right, like 0.6666, right, forever. That's 2/3, right? So how do we know when something is? Like if I gave you 0.15, right? What's this one? So here is how you make repeating decimals a fraction. Okay, so here's the first example. So what is 0.15 repeating as a fraction? Okay, so 0.15 repeating as a fraction. So first I'm going to set it equal to x because, right, we're in pre-calc. And so what we do is algebra. So x, right? And so here, I'm going to do a trick. Okay, so step 1 here is I'm going to multiply by 1 and then the amount of zeros, okay, after the 1. Okay, so equal to the length of the pattern. So what do I mean? All right. Here, right, 1, 5. So it's like 1, 5, 1, 5, 1, 5, right? So my pattern has length 2, okay? So I'm going to multiply both sides by 100, okay? If my pattern was like 3 numbers, I would multiply by 1,000. If my pattern is like these, where it's just 1 number, I would multiply by 10, okay? All right. So then, what happens? I have 100x equal to 15 point that, right? Because remember, this is 1, 5, 1, 5, 1, 5 forever. So if I multiply by 100, I'm just really moving the decimal point 2 spaces, okay? So now I have this thing, okay? And then what I'm going to do is, like, this is equation 1, and this is equation 2, and then I'm going to subtract equation 2 from equation 1, or like way later in this semester, I'm going to do row 2 minus row 1, okay? And so then what happens, okay? So let me get rid of this, okay? If I do 100 minus x, I'm going to get 99x. And right, remember, this is going on forever. So that means like the tails just kind of cancel, right, forever. So what happens is I just get the number 15, okay? And then we're basically done, right? Because then I'm just going to divide the 99 over, and ta-da! Okay. So 15 over 99. And if you do this enough, you'll realize that it's basically just, you're always going to be dividing by like 9 or 99 or 999. Like the pattern continues forever. Okay. But moving on. Okay, so these are rational. The next set we're going to talk about is the irrational, okay, or not rational. So they don't have a fancy symbol because we don't like these numbers. Okay, but these are the not fractions. Okay. So what's not a fraction? Well, if I have just like a random thing, okay, like no pattern at all, okay, and it goes on forever, that's irrational. Okay. Square root of 2, irrational. Cube root of 3, irrational. If your root doesn't like simplify, like square root 5, irrational. Square root of 4, that is rational only because we know that's 2. Okay, so unless it simplifies super nicely, it's irrational if it's in a root symbol. Okay, and then we have like the famous numbers. Okay, like pi, e, phi. Okay, if it's a fancy symbol, if it's a Greek letter, it's irrational, right? Where pi, right, 3.14 forever. E is 2.71 forever, and then this is 1 plus 5 square root over 2. And that's complicated. Okay. So, yeah. Now moving up to the final set we're going to talk about today. Okay. We're going to go into R, which these are the real numbers. And this is where we're going to do most of our work the entire semester. And the real numbers are just the rationals and the irrationals. Okay, so we combine both of them. And for the most part, this is everything you can think of. All right, this is like every number. Specifically every number on a number line. Okay, so now if you just like pick randomly, like here, okay, that's a real number. All right, if it's like 2.1875, whatever. Okay, so the real numbers are pretty much everything you could think of, except this. Okay, square root of negative numbers. That's not real. Okay, that's complex, and we're gonna talk about that way later. But besides this, everything's a real number. So now we're gonna move on. Okay, and we're gonna talk about properties of real numbers. Okay, because we have the numbers. What can we do with them? Okay, so properties of real numbers. All right, so we have the two commutative properties, okay, or commutivity. So we have one with a plus and one with a times, right? So this means A plus B is B plus A, or A times B is B times A, right? And if you want an example, right, 3 plus 4 is equal to 4 plus 3, because they're both equal to 7. Okay. All right. Not too much to say there. Next we have the associative property, or being associative. We have one for plus and times, and what this means is you can move parentheses. Okay, so like I can add this in any order. Excuse me. All right, and same thing with the time symbol. Okay, and frequently, especially with times, we don't even write the dot, right? So a lot of the times we just put parentheses, and we assume this is multiplication. Okay. All right, and then the last property is the distributive property. Okay, so this is the property where they talk to each other, basically. So the distributive property is if you have multiplication and plus, you can distribute the A to both of these. So it's AB plus AC. Okay? And then this is like not related, but the opposite, okay, is right if I have this and I pull out the A because right equal signs work both ways. So if I do the opposite thing and get A, B plus C, this is what we call factoring. Okay, so factoring and the distributive property are basically the exact same thing, just the other side of the equation. Okay, awesome. So if you notice, I haven't talked about subtraction and division. That's because they're basically the same thing. Okay, subtracting is just addition with a minus sign with negative numbers, and division is just multiplication with a fraction. Okay, so multiplication, division. So 1 divided by A is this, right? 1 divided by A. So that's the same thing as 1 over A, the fraction. Okay, and so now I'm going to go over some fraction rules just in case if you're a little rusty with fractions. Okay, so the first thing is how do we multiply fractions? Okay, so A, B, C, D. Here I have two fractions. Okay, you just multiply across. Or how I do it sometimes is like I literally just kind of connect it like this. Okay, because the answer is just AC over BD. Okay, and just a quick example: 2, 3, 4, 5. It's gonna be 2 times 3, 4 times 5. So it's gonna be 6 over 20. And you could simplify that. You could do other things, but this is just an example of how to multiply. Okay. Next, and this one's a big deal. Okay. A over B divided by C over D. Okay, so I know lots of people struggle with this, the compound fraction. Okay. Basically what I'm gonna do is I'm gonna dust off this symbol, if you remember, like when was the last time you saw this? Okay, because like if we look at this, right, like this fraction bar looks special, because it kind of is. Okay, what this means is that it's AB, okay, divided by CD. Okay, and then I don't know how you learned this, but I learned it as keep change change or keep change flip, right? So what you do is you keep the first thing the same, you change the division symbol to a multiplication symbol, and then you flip the second fraction, okay? And then now we know how to do this because we just learned how to do multiplication. So this is AD over BC. Okay. All right, and now we go how to add. Okay, so AC plus BC. All right, big deal. It's A plus B. You add the numerators, but the denominator is just the same. Okay, and if here's an example with money, right? Let's pretend I have 25 cents, also known as 1/4, and I add it to 50 cents, also known as 2/4. When I add them together, right, I get 3/4, also known as 75 cents, right? It does not work this way, right? If I did this, the same thing, and I get 3/8, like I add the top and the bottom, right? We just know that's wrong because we know how to do with money, right? So this is not true, okay? That's not how you add fractions. All right, now it gets a little more complicated though, because we had already a matching denominator. What do we do when we don't have a matching denominator? So A, B, C. Okay. What we have to do is get a common denominator. Okay, so the fastest way to do that is just multiply each fraction by the one they're missing. Okay. So right here I have a B. This is a D, so I'm going to put a D on the top and the bottom, and vice versa. So here I'm going to put a B and a B. So if we look at this, right now, these match. So the bottom is going to be BD, and the top you just add. So AD plus BC. Ta-da! Okay. And then let me get a quick example in here. So if I have 1/2 plus 1/3, I'm going to do times 3 times 3. So I'm going to get 3/6. And here I'm going to do times 2 and times 2. And I'm going to get 2/6. And now I have matching denominators. So 6/5. Okay, and that's the answer. All right, and then here's just like a bonus property with fractions that I want to make sure you guys know is if you have multiplication like this, okay, And you see like there's a C on the top and the bottom, you can cancel, okay? And it's just A over B. Okay, but this is a big deal, okay? Huge deal, okay? Do not do this is the fastest way to just lose a ton of points on the test. You cannot cancel, okay, if there's a plus or a minus, okay? If there's pluses and minuses anywhere in the fraction, you are not allowed to cancel like this. Okay, this does not work. Okay, do not do this. Okay, so hopefully that's a good enough review for your fractions. Okay, now we're gonna move on to the rest of the section. Okay, so we're gonna talk more about sets, the real line, and intervals. Okay, so a big deal that like mathematicians care about, okay, is we like to say the real numbers are ordered. Okay, they have an order. So what we mean is that we can always say some number is less than some number, or bigger, or equal to, right? So like 2 is less than 3, and we know that, right? We just look at the number line. So now I'm going to talk more about sets, and I'm going to kind of define them loosely, all right? If you want like the real technical definition, you can look in the textbook. But I'm going to define them as a collection of stuff, okay? So here I have a set because I have curly braces, and I'm putting colors in here, right? So the stuff, okay, inside of sets we call elements, okay? So the elements are colors, okay? And so one way to do sets is how I've been doing it. Right here, I'm going to have a set A, and I just have it, I'm just listing out all of the stuff inside, okay? But there's another way to talk about sets, and it's called set builder notation, and it's really important that you understand it. Okay, so set builder notation is you're gonna put just like a letter here or a variable, okay? These are what the elements look like. So here they're just gonna look like B, okay? So this is the element, okay? And then you put this bar and you have a rule. So B has to be in the natural numbers and B has to be less than or equal to 6. Okay, so everything on the other side of the bar is the rule, okay? Or how you know what your set is, okay? So now with the rule, if I wanted to, I could write this down, right? So if I go like, okay, B has to be the natural number, so you just start writing those down. And then you get to 6 and you're like, wait, 7 is not less than 6. So you just stop. And there's B. Okay? All right. So now I have to introduce some operations. Okay, so here I have like this U and kind of like this N. Big deal. They're not a U and an N. Do not write this down. Okay, that's just wrong. Okay, they are a cup and a cap. All right, and this one is a union. And this one is intersection. All right, so I'm just gonna quickly explain what these are. Okay, so if I do A union B, that means I'm combining them, or I'm making a union. Okay, so it should have everything that they both have. So right, B has 1 through 6, And A has 1, 2, 3, 6, and 7. Okay, so this is A union B. All right, now A intersect B is what they have in common. So you look at them and you're like, okay, they both have 1, they both have 2, they both have 3. A does not have 4, and it doesn't have 5, but they both do have 6. And B doesn't have 7, so we stop. Okay. So that is A intersect B. Okay. What they have in common. Not a huge deal. Okay. What is important, okay, this is definitely on your test for sure, is interval notation. Okay. So what this is when we write this. Okay. So with parentheses or with brackets or semi-open. Okay. All right. So basically what parentheses mean, okay, is that this is the everything between A and B. Okay. So if I draw a number line and I have the number A and I have the number B, how we represent this is we're going to put a parenthesis. Sometimes you learn open circle, okay, whichever one you want. I don't care. Okay. I'm going to put a parenthesis on A and B and write this is everything in between. In between. So this. Okay. But this does not include A and B, right? Like 3 is not less than 3. Okay. When you have brackets, that means that you have less than or equal to's here. Okay. So what that would look like as a picture is you go A and B, and this time you would put closed circles or you would put brackets. Okay. And this means you do include A, right? Because 3 is less than or equal to 3 because it's equal to. Okay. So it's just like, do you include the edge or do you not include the edge? Okay. And then here you can probably guess what this means, right? This means that you don't include A, so A has a less than bar, but you do include B. So this has like a less than or equal to. Okay. And the picture would be parenthesis bracket A. And then so here, this is when we can use infinities. Okay. So a tip or a fact is that negative infinity and infinity, all right, always have parentheses. Okay. They never have brackets. Okay, you should never include the infinity. Okay, so automatically I know you're wrong if I see a bracket on an infinity. Okay. But what this is just like you don't cap something. So this is everything bigger than A. This is what this means. So A greater than X. Or X greater than A is how most math people would write it. But you can choose to do whatever you want, okay? And this is an A. And basically you just go off forever. So put like an arrow. Okay. All right, so we're gonna do some examples. Okay, so examples. Negative infinity square root 2. Okay, so if you're drawing this just like casually, I would just, put square root of 2 there, and then put a parenthesis and an arrow, okay? But if you like are filling this in on a test or something, right? Or if your number line, right, if it has like numbers already on there, right? Then you have to ask yourself the question of where is the square root of 2? Okay? Right? So you actually kind of have to know where it is, because like, right, if you drew this, then you're just wrong, because first of all, the square root of 2 is not negative, right? So I know you're in the wrong spot. Okay? So here, right, hopefully you'd crunch it out. Okay? The square root of 2 is approximately like 1.4. So we'll just put it like here. And then and I'm a fan of always labeling. Okay, so just label square root of 2 here, and then you're correct. Okay. All right. Next, we're gonna kind of ramp up the complication. Okay, so 1, 3 bracket union 4, 7. Okay, so what does this look like? Well, I'm just gonna put numbers. So 3, 4, 7. So, right, just this is why I'm a fan of like the parentheses brackets, because I'm like parenthesis, bracket, parenthesis, parenthesis, okay? And then you just like fill in the insides. And that's what this looks like, right? You notice how like it's both, okay? This is what the union is doing. It's kind of like combining them, even though there's like a space in between. All right? Okay, so hopefully that's enough um interval notation. You can study more. Okay, I encourage you to study more of this. That's very important. But now I kind of have to talk about absolute value. Okay. So absolute value function. So everyone always knows it like this, right? If you're positive, then nothing happens. But if you're negative, then you get rid of the minus sign. Okay. What a lot of people don't know is the absolute value function is also just technically this. Okay, the square root of a squared. All right. And we have a property that I'm going to say is that it kind of works like parentheses. Okay, where I can split it in half like this. And if I have a fraction, because a fraction is basically just multiplication, I can split it like that over the fraction bar. Okay, so just to quickly kind of prove this to you, let me do an example of -3 times like 5. Right, if I split them, then I'm going to get absolute value -3, absolute value 5, 3 times 5. 3 times 5 equals 15. Okay, but if I do this first, I'm going to get -15, and then I take the absolute value, and I get 15. And ta-da, they're the same. Okay, so it works. Just like a useful fact. Okay. So you should know what an absolute value bar does. Okay, you should know how to use it. Let me do interval notation with it. Okay, so interval notation. Okay, so absolute value of x is less than 5. Okay, so I want this set, a equals x such that absolute value x is less than 5. So what does this mean? Okay, you kind of got to think about it, because right, this is what it does. If it's positive, it does nothing, but if it's negative, it does stuff, right? So you're kind of containing stuff, right? So if I have a number line, 5 and -5, right? You take the plus and the minus version. When you have absolute value less than a number, that just means it's stuck between the plus and the minus version, okay? But if you have the opposite thing, so I have a set, but I want the absolute value to be bigger than 5, then what you do is you do the -5 and 5, but actually you're not going to be inside because that would be smaller, right? You would be outside, okay? So it's a big deal if it's a less than or a greater than, because it literally flips whether you're inside of a set or whether you have like the two outside parts, okay? All right, but that's just like the last thing in this section. So this is section 1.1. Okay, feel free to look back at the notes, go through this video. And I'll see you for section 1.2.